Alright, so the last section of this unit, working with logarithms, is going to be the exponential and logarithmic equations and applications. Okay, great thing about this is if you looked at the one before that had the compounding interest and continuously compounding interest, this is a lot like that. So, when you're talking about the population growth and things like that, which I kind of briefly discussed in the last one, you're looking at this formula. Okay, y equals y naught, that's y naught is how that's said, e to the kt. Well, hopefully that looks very familiar if you've seen the last unit, which was a is equal to p e to the rt. Well, this is almost the exact same thing. Here, a was my accrued amount, y is still the accrued amount. Okay, most of us prefer to think of it as that final amount. Okay, the final amount, whatever your population is growing to, okay, or ending at. That's what your final amount is. So y naught, okay, y naught is the initial amount. Okay, and y naught is just like our p value here. P was the principal, how much we invested. This is your initial amount. Okay, E, remember, is its own number. K is our rate. When you're looking at money, which is what this one here is for, okay, R is going to be your interest rate. Here it's just your rate, okay, and T is going to be a time, just like it has been, only here it was always years. This one, it can be any unit at all. Okay, this one doesn't matter. It can be any unit at all for time on this one. It is super important, and I want to point this out, that your rate and your answer need to match up. So, when your rate is, say it's daily, okay, if they say 6% daily, then that's your rate. Your rate is in day units. So when you go to answer, your answer is going to come out in days. Okay, so if they ask you to find how many weeks, then you would have to convert. Or vice versa. If they give you a weekly rate, so 3% weekly is what the increase is, then, and they want you to find how many days, then you have to convert when you get to the end. So please keep that in mind. Alright, so here, the population size y of a community of lemmings varies according to the relationship y equals y naught e to the 0.15 t. In this formula, t is time in months, and y naught is the initial population at time 0. Estimate the population after 6 months if there were originally 5,000 lemmings. So let's pick out our important information. First of all, they were nice enough to input your k value for you. See, e to the kt. We got e to the 0.15 t. So they input k value for you. That's very nice of them. Now we also have a whole lot of information that doesn't need to be there. Estimate the population after 6 months. Okay, estimate the population. So I'm looking for my final population. They give me 5,000 originally. So this is my initial amount. Okay, that's what that naught means. Okay, it's a little zero, if you will, but it's called a naught. And the naught refers to the initial amount. You can see it in physics and things like that. Also, if you ever see V naught, that means initial velocity, although some people use VI. These two things mean the same thing. If you see VI, which is initial velocity, and V naught, those are the same thing. Okay, so Y naught means initial. So they give me my rate, they give me my time is 6 months, they give me my initial amount, so I'm just going to plug in to our formula. So here we go. So y is equal to 5,000, okay, e to the 0.01 or to the 0.15, I'm sorry, okay, to the 0.15 t, and t here is 6, and notice it says months. Okay, so keep that in mind. So now they want us to figure out what the population is going to be after that 6 months. And if you look at this, this already says y equals a bunch of numbers. Okay, remember e is a number. So you don't have to do anything to it. Okay, you just plug it in. Well, when I'm looking for y, I don't have to use the log or anything like that. This is a little different. If I was looking for t, t would be up in the exponent spot, in which case I would have to use the log to get it down. But since I don't have a variable up in the exponent, I don't need to use the logarithm yet. So here, I really just plug it in. So here we go, 5,000 times E. If you look underneath the natural log, okay, which you can't see because I'm pointing at it and it's not on the screen. Underneath the natural log, it says e to the x power. Okay, if so right there next to the 4, there's the LN button, and underneath that is the e to the x button. So you hit second, natural log gives me this, e raised 2. So this means e raised to, well, what's my exponent? My exponent is the entire thing, 0.15 times 6. Notice that I have the entire thing in parentheses because it's not just e to the 0.15. It's e to the 0.15 times 6. So I have to have a set of parentheses around them to show that they're both part of my exponent. Okay, so then hit enter, and that would be my new population. So y is approximately, okay, and we are going to round to the nearest whole. You're talking about populations. I don't want to cut lemmings in half. They're little rodent-looking things. I don't want to cut them in half. So we're just going to do 12,298 lemmings. Okay, so 12,298 lemmings. Okay, so round up to the whole number on population. Okay, for that matter, when you're talking about money, by the way, you should always round to the nearest cent. Okay, round to the nearest cent, not to anything else. With money, you round to the nearest cent. Okay, now, so same sort of idea here. The population of bacteria spreads at a rate of 7% per hour. Okay, it says per hour. That's my rate. That's not my time. This is my rate per hour. If the initial of shouldn't be there. If the initial amount of the bacteria was 75, how long will it take the bacteria to double? Okay, so how long? So here we go looking for T again. Okay, looking for T. And we're trying to find out when it's going to double. So my Y naught is how I started, the 75. And my doubling would take from 75, I'd get to 150. So they want to know how long does it take for my bacteria to spread to 150. Okay, so plug that stuff in. You get 150 is equal to Y naught, which is 75, e to the rate, which when I convert that is 0.07, so rate is 0.07 times T. Now here, it's not like the first one. Here I had Y equals what I wanted already. Y was what I was looking for. Here I'm looking for T. I don't have T equals, so I have to make T equals first. So we're going to divide by the 75. Yet again, just like in the last lesson, if I'm doubling, I should end up with 2 here. Okay, if I want to bring the T down, I need to take the natural log of both sides. And that way I get the natural log of 2 is equal to, remember, natural log of E crosses out, and I get 0.07T. So I've got the natural log of 2 is equal to 0.07T. Divide by 0.07 on both sides, and I get T is approximately, okay, so natural log of 2, sorry, let me put that back on the screen there, natural log of 2, close parentheses, divided by 0.07 gives me approximately 9.9. We'll go to 2 decimal points again. It doesn't say how many decimals to go to. Okay, this is time. This isn't the same as this one. This one I rounded to the whole because I was talking about an actual thing. This is an animal. So we're going to round to the whole. Here we're talking about time. Time can be in decimal form. So 9.9, this was 7% per hour, so that makes this hours. Okay, so then the next one. In 2002, Canada had a population of 31,902,268. How long will it take Canada to double in populations if its growth rate is 0.8% annually? Okay, so here is my initial. Okay, I am doubling, so that's going to be my Y. My rate, don't forget to change it. It still has to go 2 to the left, so you get 0.008 for my rate. Okay, and I'm trying to find time. Plug it in. So doubling, if I want to double that number, 31902,268 times 2, I get 63,804,536 is equal to 31,902,268. Of course, if you've been paying attention, you really don't even need to do this step. You didn't have to multiply it by 2, because what's going to happen if it's doubling? Once I divide this over, and again, if you've been paying attention, you've already seen this. Okay, when I divide this over, since it is doubling, it's going to end up equaling 2. Do it. 63 million, what, all that stuff divided by that equals 2, because it's doubling. 0.008t. So if you wanted to skip ahead to this step, I am perfectly okay with it. You don't have to write all of this out if you show that you understand that it doubles to 2. Now be careful, don't skip too many steps, because a lot of people are skipping a lot of steps on their homework. We're getting a little lazy and you're losing points for it. So make sure you at least show this step here to show that you understand there's a 2, and then show the conversions after that. So natural log of 2 is equal to the natural log of e to the 0.008t. And that goes away, so I get the natural log of 2 is 0.008t. Divide by 0.008, and you should get t is approximately natural log of 2 divided by 0.008. And I get t is approximately 86.64, and this was annually, grows annually, so annually means it's done in years. Okay, annual means years. So 86.64 years for the Canadian population to double. Okay? So, go ahead, do the on your own. When you finish doing the on your own, which I'm going to do here in just a second, then I'll discuss one more thing as far as the decreasing rates, which aren't actually in your packet here, but we will talk about them very quickly. So, first try the on your own, and then I'll toss those decreasing rates at you, and then you will be done. Alright, so 2002, Egypt has a population of 70,712,345. Big number. How long will it take Egypt to double in population if the growth rate is 1.6% annually? Okay, so yet again, I could totally skip ahead and just do the 2 equal to e raised to the 0.0016. Oh, sorry, too many zeros. Okay, move the decimal twice, 1, 2, so 0.016t. I could skip to that. I'm going to show you in case you still don't understand the skipping part. But, okay, I have an initial amount of this. If I double that, I would have a final amount of, let's see, 70,712,345 times 2 is going to be 141,424,690. Big numbers, big numbers. It's going to be big numbers. You're talking about population, okay? Populations are very, very big. So this is my initial amount. So if I didn't skip ahead to this, then I would get 141,424,690. Sounds like some really long phone number or something. 7071235. That should say equals, okay, e to the 0.016t. Okay, really big numbers. And then when I divide here by 70,712,345 to both sides, 70,712,345, those go away, and that equals 2. E to the 0.016t. So that's why I'm able to just do that skip, because I'm doubling. So that thing, and this only works if you're doubling. If you're not doubling or tripling, then you can't just skip that step. You're going to have to write it all out and divide it out. But If I'm doubling, I can skip ahead and just jump straight to there. Alright, so then natural log both sides. Natural log of 2 is equal to, I'm going to go ahead and drop this exponent down, natural log of e, which goes away. Divide by the 0.016 on both sides. And t is approximately okay, so I've got the, let me give you the exact over here, natural log of 2 over 0.016. So the natural log of 2, close that, divided by 0.016 is 43.32, and this was given annually, so that's in years. Okay, so approximately 43.32 years for Egypt's population to double at that rate. Okay, so the last thing that I have to kind of discuss with you is really just the use of decreasing. Okay, when you talk about decreasing, so let's say for instance I have a population of 1,000 and it's decreasing at a rate of, I don't know, we'll do something nice. Decreasing at 5%. Okay? So if I'm decreasing at 5%, the only thing that's going to be different here is that when I put this in, it's going to be a rate of negative 0.05. You do a negative rate, I'm sorry. So when I'm decreasing, the rate is going to be negative. So you get negative 0.05. So let's say I started with an initial amount of 1,000 and I want to double, okay, to 2,000, and I want to find the time. Okay, so I want to find the time. So, I'm sorry, I'm decreasing. Oh, goodness. So if I have an initial amount of 1,000 and I want to know how long it takes to decrease by 1/2. Okay, so I want to go down to 500. So I'm decreasing at 5%. Okay, so if I want to know how long it takes to go from 1,000 to 500, I have a decreasing amount of negative 0.05. So when you plug that in, it's going to be 500 is equal to 1,000 e to the negative 0.05 t. I still solve it all the same way. I'm going to divide by 1,000. I'm going to get 0.5 is equal to e to the negative 0.05 t. I'm going to natural log both sides. Okay, so I'm going to get negative 0.05 t on the right hand side. I'm going to divide by negative 0.05, divide by negative 0.05. And when you do, that should give you a positive answer. If you don't get a positive answer, then something kind of went wrong there. So, for the time anyways, okay? So when you do the natural log of 0.5, divide that by the negative 0.05, and you get a positive time of 13 hours. So, please keep that in mind, that if I am decreasing, then I'm going to use that negative rate. And if I'm looking for my final amount, keep in mind that my final amount should be smaller than my initial amount. Okay, if I'm a decreasing population, then I'm going to get smaller, not bigger. So, just little things to look out for when you're doing your homework and things of that nature. I hope that helps.